Good afternoon, my YouTube viewers. It is Crystal here. I'm just here because I wanted to do a code review for you, and this is an interview question where you're supposed to build a decision tree classifier on the iris dataset. And so I did that today, this morning really, and I just decided that I was going to do a code review on it. But it is an interview question that may come up during an interview, so you need to be familiar with how to actually make a decision tree classifier and do what the interviewers ask you to do. So I've written this program in Google Colab, which is a free online Jupyter notebook. But the only problem with Google Colab is it doesn't really have an adequate undo function. And so you have to be careful not to overwrite or delete valuable code. If you do, there's a possibility that you can go into the save history to retrieve it, but it's not a guarantee. So after I have created my Jupyter notebook, and I've called it Iris Decision Tree, and I'll just say classifier, just to make sure people know it's a classifier. The first thing I do is I import my libraries. So basically, in Python, strictly speaking, you're supposed to import all of the libraries at the beginning of the program. I don't always do that, but I decided I'd go ahead and do it on this occasion since it's an interview question and you're going to need to make your program as pristine as possible so the interviewers will know what you're doing. So the interviewers will believe that you know what you're doing. So the libraries that we're going to import are NumPy, SNP, which creates NumPy arrays and performs numerical computations. Then we're going to import Pandas, SPD, which reads in the CSV file, the dataset, and converts it to a data frame. We're going to import pandas.plotting, import scatter matrix. So we're going to make histograms or scatter plots and histograms of the different features. We're going to import sklearn.model-selection train test split, which is going to split the data set up into training and validation sets. We're going to import sklearn.tree.DecisionTreeClassifier. That's going to be your model. We're going to import sklearn.metrics.confusionMatrix. And so what that's going to do is it's going to tell you which classifications are correct. And then we're going to import sklearn.metrics.accuracy score. So that's going to tell you the accuracy of the model. We're going to import sklearn.metrics.logloss, and that's like a goodness of fit measurement, and we will talk about that when we get to it. We're going to import sklearn.tree, and what that does is that actually makes a tree for you of your model. We're going to import matplotlib.pyplot as PLT, so that's going to visualize your data, and we're going to import Seaborn as SNS, and that's going to statistically visualize the data. So after we have imported the libraries, then we're going to use Pandas to read the CSV file in and convert it to a data frame. So you can see in this data frame we've got sepal.length, sepal.width, petal.length, petal.width, and variety. So you've got three classes. So we're going to analyze the data frame. So what we do is we create a SNS.histplot DF variety. So you're going to create a histogram of the target, which is DF variety. And then you'll see you'll have 50 each of Setosa, versicolor, and virginica. So you also want to see the value counts of each class. So you see we have 50 each again of Setosa, versicolor, virginica. Now we're going to create histograms of the 4 features. So you've got a histogram of the sepal width, histogram of the sepal length, histogram of the petal length, and the histogram of the petal width. So you can look at that and analyze it. Now we're going to do a scatter plot matrix. So it's going to perform scatter plots against each feature. That's what it's going to do. And so if you want to analyze that, then you can analyze that as well. We're going to define the X and Y variables. So Y is going to be df.pop variety. So variety is your Y variable and it's popped out. And X is your df. And then we're going to print the shape of it. So you'll see that we have 150 rows of data for the X and the Y variable. Now we're going to use train test split to split the data set up into training and testing sets. The test size is going to be 20%. So you have 120 of the training set and 30 of the validation set. So now we're going to create model. The model is a decision tree classifier. So CLF equals decision tree classifier, random state equals 42, fit X train, Y train, and it gives you a score of 100%. So what that means is it predicted the accuracy was 100% on the training set. Now what we're going to do is we're going to predict on the validation set. So ypred equals clf.predict xval, and then so there's your ypred, and you've got versicolor, secosa, setosa, and virginica. Now we're going to check the accuracy of the validation set, and you have 100% accuracy of the validation set. Now we're going to check log loss. Log loss equals yval and clf.predict proba xval. And so you have a log loss of 4.44. So let's just see what log loss is. So how to calculate, just say what is. It is a goodness of fit test. It is a goodness of fit test. Log loss, aka logistic loss or cross entropy loss. This is the loss function used in multinomial logistic regression and extensions of it, such as neural networks, defined as the negative log likelihood of a logistic model and returns ypred probability for its training data y true. Says what is the log loss function in Python. The log loss can be implemented in Python using the log loss function in sklearn. In the binary classification case, the function takes a list of true outcome values and a list of probabilities as arguments and calculates the average log loss. And then so we'll say what is log loss used for. Log loss, also known as logarithmic loss or cost entropy loss, is a common evaluation metric for binary classification. It measures the performance of a model by quantifying the difference between the predicted probabilities and the actual probabilities. So I think you want your log loss to be as small as possible, because if it's calculating the difference between the predicted probabilities and the actual values, then you're going to want the difference to be as small as possible. That's what I'm just taking an educated guess here. And then after we've done our log loss, we're going to do the confusion matrix. And the confusion matrix just tells you how many true positives you have and false positives and true negatives and false negatives you have. But in this particular instance, you've got 100% accuracy, because the IRIS data set is a very easy data set to make predictions on and to experiment with. Okay, now we're going to create a classification report. Classification report is a report that tells you how well your model is working. So we can just look here. Classification report visualizer displays the precision, recall, F1 and support scores for the model in order to support easier interpretation and problem detection. The report integrates numerical scores with color-coded heat map, but we didn't use that on our classification report. We just used the standard one from sklearn. So here's the question: what does the classification report mean? Classification report is often used in machine learning to compute the accuracy of a classification model based on the values from the confusion matrix. Okay, so there's some information about the classification report. And then the last thing we're going to draw up is a tree. And this is the actual tree of the model. I can't see it very well, but if you expanded the view, you can actually see the tree, see what the tree looks like in the model. So this is your decision tree classifier, and you'll be asked a question on an interview to create the decision tree classifier with IRIS dataset. And then so at the very least, you're going to have to know how to import your libraries, how to convert the CSV file to a data frame, how to determine what your target is, how that's your dependent variable, how to determine the features for the independent variables, how to split the dependent variables and independent variables up into X and Y, how to split the data set into training and validation sets, how to define your model with the decision tree classifier, and how to compute the accuracy. And then, if you wanted more, you should definitely use a confusion matrix, because the confusion matrix will tell you which ones you got right and which ones you got wrong. And anything else you can do is just a bonus. So it just depends on how much time you have, how familiar you are with using the software, sklearn in particular, and what the interviewers ask you. So I'm going to go ahead and close this video, because I've covered the decision tree classifier and all of the attributes that go along with this.